This is Josh White with JW Math Tutoring. In today's video, I'm going to go through 10 problems from the math section of the August 2025 Digital SAT exam. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Just before I begin going through this first August 2025 Digital SAT Math problem set, I want to mention a couple things that I always talk about at the start of these videos. First, I've gathered these problems from various sources, mostly Reddit, but also some from Discord. So I've tried to make the problems as accurate and as realistic as possible, but there might be some details that I'm missing compared to if you actually saw this question on an official exam. So just keep that in mind. The questions might be slightly different than what you saw on your exam. Some of these questions might have been multiple choice on your exam, whereas here they are free response. So just keep that in mind, as we're going through these problems. Second, there'll be a PDF file where you can download a blank copy of these problems. It'll be in the description of the video, also linked in the pinned comment. Related to that, all my links are going to be changing to a different server because I basically blew through the bandwidth, my current host for the PDF files last month because so many of you were downloading, my problem set worksheets, Desmos guide, Desmos practice problems, and everything. So I'm going to be migrating everything over to basically a new host. So just be aware of that. Also keep in mind, if you do like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And I think that should pretty much be it. There's going to be 4 total videos or another 4 total worksheets, each with 10 problems. So like 40 total problems from the August 2025 SAT. And I've tried to arrange each of the videos or the worksheets such that the repeat problems are towards the end, basically like the last 3 or 4 problems, and the first 6 to 7 problems are meant to be the new ones that we have not seen before. So with all that being said, let's go ahead and get started here. We have the problem with the steel pipe. And so basically, what's going on here, I'm going to try to draw a picture as best I can. I don't think I can draw 3D pictures in OneNote. So basically, you have this pipe, okay, and I'm going to exaggerate it just to make sure we understand what's going on. You have this steel pipe, and basically, this technically down here you wouldn't be able to see. Again, you wouldn't really technically be able to see that opening either. But the diameter, so total distance from side to side, from the outside, okay, is 60 inches. The height is 130 inches. And then basically, just like a pipe, it's hollowed out. There's nothing in the middle. So the pipe has a certain thickness, and that thickness, basically from here to here, or whatever direction you're looking, same thing here to here or on the other side, 5/8 of an inch. Okay, the question is asking for what is the volume of the steel pipe itself. So in other words, it's like if you filled in, just this area and then extended it all the way down, what would that volume be? And of course, the whole inside here, you can't see it because it's inside of the pipe, but the whole inside here, would be essentially hollowed out. All right. So basically what we have to do is find the volume of the outer cylinder, then find the volume of the inner cylinder. Inner cylinder is basically the hollowed out part here, right? Outer cylinder is this outside part. And then just subtract those two. And that's going to give us the volume of basically the thickness of the pipe, or think of it as like the donut, so to speak, in the picture here. All right, so of course we know that the volume for a cylinder, the general formula is just pi r squared h. Now you do have to be careful because you're given the diameter, which is 60. That's all the way across, which means the radius of the larger one. So I'm going to do everything. So here for the outer, The radius of that is going to be 30. We do not use the 60 because 60 is the diameter. We want half that. So we know the radius is 30. We know the height is 130. And so now we can just plug everything in. Pi times 30 squared times 130. So let me just look at my notes here. It should be 117,000. I mean, I'll go to Desmos just to confirm these various calculations. Sorry, 117,000. I forgot the pi technically, but when we go to get the answer, they're only looking for the number in front, or the constant in front of the pi. So the 117,000 is really what we're concerned with. Okay, so now let's just confirm this. In Desmos, 30 squared times 130. Okay, yep, 117,000. All right, so for now, we can find the volume of the inner cylinder. You do have to find the radius first, though. Height's still going to be the same at 130. So here's the thing. The radius here is basically going to be 30, the radius of the outer, minus 5/8, which is the thickness of the pipe. So 30 minus 5/8 is going to be the radius of the inner cylinder. So you can make that into, you can put that in Desmos however you want. You can think of it as like 29 and 3/8, or you could do the decimal form, 29.375. So whatever, we'll just do that. And then you can plug that into the formula. Now, of course, this is not going to be a nice integer, but that's fine because you just have to round the answer at the end. So now we've got 29.375 squared times the 130. Okay, so it's 112,175.175. What was it? 78125. Okay. Of course, on the test, you wouldn't necessarily need to write all this down because you're just doing all the calculations in Desmos. All right, so now we can go ahead and subtract those two numbers, and that is going to give us basically the volume for the thickness, essentially, of the pipe itself. So now we can just go to Desmos. I'll just call this one, set this one equal to O for outer, so I don't have to retype it. I'll set this one equal to capital I for inner, outer minus inner. All right, so we get, and again, we're ignoring the pi here, right? So we get 4824.21875. We want to round this to the nearest whole number, therefore it just gets rounded to 4824. So it's 4824 pi, but again, n is the number here in front of the pi, so 4824 is what you would report as your answer. All right, let's look at the next question. Here we have a cone. Just get rid of some of this. And you're told its slant height, and you're also given its regular height. So just draw a basic picture here. We got the height coming down perpendicular, 15. We've got the slant height, which is basically like right here. It's the hypotenuse of a right triangle, 25. And we want to find the volume. And again here, we want the constant that is attached to the pi. So we're basically just ignoring the pi. All right, so this is actually not that difficult a problem because we need to find the radius, because the volume formula is basically 1/3 pi r squared h. We already know h, that's 15. We just need the value of the radius. And that we can just find by doing Pythagorean theorem. 15 squared plus r squared equals 25 squared. R squared is going to be 400. R is going to be 20. You can just confirm this in Desmos. And one of the best uses of regression that you can do is basically typing in a Pythagorean theorem equation exactly as it's given and not needing to do the squaring and then move a term over and then square root both sides, but just type it in exactly as it is in a regression statement and you get the answer right there. So r is 20. Now we can just go to the volume formula, plug everything in. So we got 20 squared, we've got 15, 3 goes into 15 5 times, 20 squared, 400. Notice you actually, since the formula actually has r squared, like if you did it by hand, once you get down here, you could actually just plug the 400 in. But in any case, it comes out to 2,000 pi, and therefore k is going to equal 2,000. So 2,000 is the answer that you would fill in for this problem. All right, let's look at the next one, question number 3. You have this given linear inequality, and you're told that when x is 18, find the smallest possible integer value for y. So basically that just means you plug in 18 here, 16y plus 3. Then if you solve this essentially for y, so minus 3 both sides times 6 both sides, okay, 90 is less than y, or if you rearrange it like this, y is greater than 90. So what's the smallest possible integer value? Well, it has to be 91. And that's your answer. Now, this would have to be worded like this with the word integer in it, because if you didn't have integer, if it just said smallest possible value, I mean, then you could, it's basically like 90.00000, an infinite number of zeros, and then like a 1 at the end, you know, just to technically make it larger than 90. So there's no, the point is there would be no definitive answer in that case. So just something to keep in mind. Now, of course, you could go to Desmos and do this. Basically, what you would do is just type in the inequality as given, and then you're concerned with when x is 18. So let's zoom out here. Let's type x equals 18. Okay, so everything in the blue is basically the solution set. Those are the possible values for x and or y. So notice here, oh, I typed it wrong. I typed a 3 instead of a 6. That's why it's the wrong point. Okay, always double check what you type into Desmos. Good lesson to learn. So now here, we're at 1890. We're on the border. Therefore, when x is 18, the smallest integer value would then have to be 91. Okay, it can't be 90 because it's not less than or equal to. So therefore, it has to be just 91. And this is how you could solve this, or just at least visualize it in Desmos. All right, let's go to the top of the next page. Here we have a basic system of equations, and it wants to know what's the value of 0.25x plus 0.25y. So this problem that I got doesn't appear to have any type of, I don't know, like shortcut that a lot of them do, where you either add the two equations together and it gives you the expression you're looking for, or you subtract them, or you multiply one of them by something and then add them. So at least as part of it was given, and as I tried to reconstruct it, you know, basically the easiest way to do this is just to go straight to Desmos and get the answer. And I'm actually going to demonstrate how to do it using a system, using regression for the system of equations. If you don't know how to do this, have never seen this before, then please do check out my Ultimate Desmos Guide to Digital SAT Math. You'll learn how to do this, plus tons of other useful things. So we type equation 1, top equation left, comma, bottom equation left, then the tilde, and then another set of brackets, top equation right, comma, bottom equation right. We have our two answers, and now we can just do 0.25x1 plus 0.25y1 and get our final answer of 6. Now you could have graphed this one as well, and just gotten the intersection point and gone from there, but I just wanted to show how to do this one using regression, just because not everyone knows how to do that. All right, next up, question number 5. Here we have a trig problem. So you have this equation. You're told p is a constant greater than 98. Find the value of p. All right, so first I'll go through the theoretical approach to it, and then I will show you just how you could back solve it, basically in Desmos. So if you're familiar with the unit circle, or like basic trig values, you would know that the sine of pi over 4 is equal to positive root 2 over 2. That means this expression inside here has to equal pi over 4. So if we set them equal, pi's can be canceled out. Just divide by pi on both sides. And then, so now you have a 1 here. You can cross multiply, and you just get p equals 49 times 4, or 196. Correct answer is letter C. But here's how you could just do it in Desmos. So what I would do is I would type, first I would type square root of 2 divided by 2, just in case you're not familiar with that decimal. Then I would type the sine of 49 pi divided by p. I would add a slider for p, and I would just go through the various answer choices. So first, I would plug in 98. Okay, do the two numbers I see in rows 1 and 2 equal? And the answer is no. So then I would go to 147. Do they equal? No. Then I would go to answer choice C. Do they equal? Yes. So that's the correct answer. And then if you check the last one, you'll see they do not equal, just confirming that it is letter C, which is correct. All right, next up, we have a circle, and we have its center, and we have a point that it goes through. Basically, this point is also on a line, which is tangent to the circle. What's the slope of the line? All right, so basically what's going on here is you have -2, -4. Down here's the center, and then -7, -5 would be like right here. Okay, so the circle, I don't, looks whatever, something like this. Horrible picture, but doesn't matter for our purposes. Okay, and then you have a line which is tangent to the circle, that looks something like that. All right, so basically what we need to do, let me just -4, -5. Yeah, okay. So let's go ahead. First, calculate the slope from the center of the circle to this this point of tangency, to the point that we're given. Okay. So what I'm going to do is just do -4 minus -5 on top, and then -2 minus -7 on the bottom. All right, so now when I do this, I get a slope of, let's see, on the top it's +1, on the bottom it's +5. So the slope of this radius right here is 1/5. Now, any line which is tangent to a circle is perpendicular to the radius drawn from the center to that point of tangency, i.e. we have a right angle. That means the slope of this line M must be the opposite reciprocal of this number. So therefore the slope of line M is going to be -5. So the correct answer for this one is going to be letter B. Now, you could obviously like go to Desmos and do this work here, and you could try to plot out the circle and figure out like the distance of the radius or whatever to visually map this, but I don't think it would be any quicker or easier, than just doing essentially this method right here. And of course, for the slope calculation, you could just go to Desmos, you could make a table, you put in the 2 points, and it'll give you the slope of the line, say, rather than doing this by hand. So here, we'll just show that real quick. But then you do have to still remember you got to take the opposite reciprocal of it. So in other words, you could just go to the table here, and you could do -2, -4, -7, -5, and then just click on linear regression. Okay, so here the slope is 0.2, so then you have to know, okay, it's going to be -1 over 0.2, and it gives you -5, which is your correct answer. So that's just how you could do the actual, again, calculation work in Desmos. All right, let's look at number 7. Here we have another kind of like perpendicular line type problem. So you have two lines that are perpendicular, and they intersect at this point, 5, 16. One of the lines goes through the origin. So just to kind of like sketch out and see what's going on here. So one line goes through the origin, and then it's like whatever. And way up here, it goes through 5, 16. So this is, line J. Then you have another line which is perpendicular to it, so whatever, it's going to look something like this. This is line K. And line K passes through P0. Notice that this is really the x-intercept point because the y-coordinate 0. They want to know what is the value of P. In other words, what is the x-coordinate of the x-intercept is what they're looking for here. Okay, so a couple things. The slope of line J is going to be 16 over 5. And I can just tell that because it's like 16 minus 0 over 5 minus 0. You know, it's 2 points, y2 minus y1. Okay, so its slope, 16 over 5. Now, that means the slope of line K, since it's perpendicular, is going to be negative 5 over 16. Now we have a slope, now we have a point. We can use that to get the equation of the line, and then once we have the equation, we can get the x-intercept. So, I guess I'll just go in general. I'll show you how to do this by hand, but I'm not going to spend time doing all the actual like workout because you could just do this entirely in Desmos and it'll probably be much quicker. But we've got y equals mx plus b, so we know that y equals m times x plus b. Okay, so you go ahead and solve this equation for b. The value that you get should be 17.5625. So let's just go to Desmos and confirm that and just show you how I would do the entire thing in Desmos. So again, if you wanted to do the part for line J, we put in 516, we put in 0, 0. I'm going to type the linear regression. Okay, so we get its slope as 3.2. That's also equivalent to, so just to confirm, that is equivalent to 16 over 5. Now, the slope of k will be negative 1 over that, which is right there, negative 5 over 16, or negative 0.3125. All right, so now, basically for line k, what I'm going to do is make a table. Got the 0.5 over 16. Now I'm going to do a regression, but I have to type in the slope. I can't type negative 1 over m because m is already being used in a different regression and you can't like carry it over from one regression to the other. All right, so I typed x1 here by mistake. Sorry, this should be x2 for my second table. There we go. All right, 17.5625. Is that the, yes, that is the same value I got just doing it out, essentially by hand in my notes. All right, so now we have the equation of y2. Let's zoom out and now see for the x-intercept, all you have to do is just click on this point here. So 56.2, and that's it. That's the answer. You could also put it in the equivalent fraction form, which is 281 divided by 5. So let me just check here one thing. Yep. So again, the value for P, it's 56.2 or 281.5. Either of those would be accepted as correct answers. All right, number 8. This is a repeat that I think first appeared on the June test. You have an equation here. You've got something like a 2n root, and x to the n. So the way you solve this is you raise both sides to the 2n power. And on the right side, that essentially cancels out. The same way if you have a square root and you square something, the square root and the squared cancel out. So you get 6x to the n plus 27, and you get x to the 2n minus 6x to the n minus 27 equals 0. This is basically like a quadratic, and you just factor it as x to the n, and then minus 9 plus 3. So x to the n equals 9, x to the n equals negative 3. You can't have this one because n is a positive integer. So x to the n equals 9, and that's your answer. Now, you can also do this in Desmos, of course. I'll show you just how to do that briefly. Delete all this old stuff here. So what you would do is you would type a regression statement. We need an nth root, so I can enter the index as 2n. Okay, now All right, so I want to set n equal to 1. Notice when you do that, it returns the 9 that we're used to. However, what I want to show you is, if I also do x to the 1 n down here, notice when I'm going to drag the slider for n, it's going to change the x1 value up here in the regression statement. But the x sub 1 to the n, which is what the question is asking for, is not going to change. It's going to remain constant at 9. So watch this. Notice it is staying at 9 no matter what the value of n is, as long as it is positive. Okay, so this is just how you could solve this entirely in Desmos in about, I don't know, 30 seconds, 40 seconds maybe. All right, next we have a quadratic. This, again, very, very similar concept that we've seen before. You have a quadratic equation with a constant. You're given the solution. The solution actually had another constant in it, but it didn't, that really doesn't affect anything. So if you're going to solve this by hand, what you would do is you would multiply out the left side and subtract the right side over. And then you would do quadratic formula, which would be negative b, plus or minus square root b squared minus 4 times a times c, in this case is technically negative c, over 2 times 1. And then you get 8 over 2 plus or minus, and inside here it becomes 64 plus 4c. Okay, now if you're trying to match this, notice that this is technically over a 1. So really, there's multiple ways you could look at this. The way that I did it is I basically said, okay, how can I get rid of this 2 on the bottom? Well, it can divide into the 8, but we also need something out front here for it to cancel out with as well. So you factor out a 4 from the 64 plus 4c inside the square root, and then that 4 will go outside as a 2. So then what you would be left with is, you have a 2 here, you have 16 plus c, cancel, cancel, cancel. So now we have 4 plus or minus root 16 plus c. And this is basically equal to k plus 9 root 2. Okay, so first of all, k equals 4. That doesn't really matter for our purposes, but now essentially what you're doing is you're equating these two square roots right here. So the way I would do that is I would bring the 9 back inside, and technically it goes inside as a 9 squared. So that means you have, basically just for the part under the radical, 16 plus c equals 2 times 81, or 162. Therefore, c would equal 146, and that would be your final answer. Now, here's how you could solve this entirely in Desmos. So what I'm going to do is, I'm going to type the first equation just as a function, which means I am going to subtract over the c. Okay, now what I'm going to do is, I'm going to note that when I evaluate this given solution in the function, since it is a solution, the expected output is 0. Now, here's the problem. If you notice, if I plug this in, right, it's giving me k equals 1 and c equals some random number. It's not giving me 146. This is not correct. This is not what we're looking for. What you have to do, and the reason it's happening is because there are two constants here. There's a c and a k. What you have to do, or what you have to recognize, is that if one solution is k plus 9 root 2, the other solution will be k minus 9 root 2. Therefore, you have to go into Desmos, and you technically have to set up it's like a system of equations where you have both of the solutions, and you are doing regression with both of, and setting both of them equal to 0. Then it works properly. It finds the value of c is 146. It finds k is 4, and we get our correct answer. Okay, So just keep in mind on a problem like this, where technically the reason I have to do this is because I have two constants. So it technically needs like two constraints or two things to check against in order to work. All right, now let's look at the last problem, number 10. This is an advanced percentage problem. You can do this one entirely in Desmos. I will show you how to do that just after I show you just briefly how you would set it up by hand. So first, 68% of h, 0.68h equals 0.92j, 92% of j. And we know j is also equal to 0.34, 34% of k. What percent of k, I'm just going to call it p percent of k, is or equals h? So these are your three equations. And you could take the first one and you could solve it for basically for j by dividing by 0.92, and then you would replace j in the second equation, and then you would want to solve the second equation we want to relate h and k. We want to divide by 0.68. What am I looking? Yeah, we want to divide by 0.68 and then plug that into let me start over. Divide by 0.92. That's what j is equal to. Then you replace that in the second equation right here. Then you have an equation with just h and k. And then you want to solve for h, which means you need to get rid of the 0.68 and the 0.92. Okay. And eventually get h alone equals some decimal times k, and that decimal is your answer. But with all that being said, let me show you the quick and fast and easy way to solve this entirely in Desmos. So what I'm going to do is, again, it's basically setting up a system of equations using regression. This is covered, by the way, I think it's in part 12 of my Ultimate Desmos Guide to Digital SAT Math. So go check that out if you want to see more examples of this or the process explained in greater detail. All right, so we've got 68% of h. All right, and then what I'm actually going to do is, so that is equal to 92% of j. Then we know j is equivalent to 34% of k. Now, this part, this what percent of k, I'm just going to use p. So p percent of k is equal to h. And there's our answer. P is 46, which is the correct answer. It's 46%. So that's it. You can do this problem entirely in Desmos. You don't need to do any work by hand. I mean, I guess if you want to, basically you're just taking each equation and like replacing the is equivalent to with an equal sign, and you can just type the percentages straight in there, equal sign, and then for the what percentage, just pick whatever letter you want to use, p percent, c percent, a percent, doesn't matter, and it'll just calculate the whole thing for you. Okay, and right there it's 46. That's the percentage. That's what you enter in. You don't enter in the decimal equivalent. You just enter in 46. All right. So I hope you enjoyed this video. Basically, the first August 2025, worksheet or problem set. If you have any questions or comments on these problems, please do leave them below, or alternate solution methods as well. If you did like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Obviously, check out the videos, the worksheets for part 2 and part 3 and part 4 once those are posted. And lastly, of course, if you're looking to improve your knowledge of Desmos, check out my Ultimate Desmos Guide to Digital SAT Math. It is up to over 5 hours in total now. I have 65 total practice problems, and it covers all kinds of advanced techniques, including many that use regression to help you ace the digital SAT math section.